Hi, good evening, everyone. Now we are going to discuss about another question, which is about the partial pressure and mole fraction. So if we see over here, this is a multiple choice question type, but then let's see the questions. So 3.6 moles of hydrogen gas and 2 moles of iodine vapor are placed in a reaction vessel, which is then sealed and maintained at a constant temperature. So it means that there isn't any increase of the temperature. Yep. And then after that, the equation is shown. Okay, so from this equation, we know that the equilibrium constant of pressure for this reaction equals to the partial pressure of hydrogen iodide, yep, increased to the power of 2, to the power of 2 divided by the partial pressure of hydrogen multiplied by partial pressure of iodine. Okay, so because what we know is the moles, yeah. Okay. Now, after the reaction, it means at equilibrium, 3.20 moles of hydrogen remains. So all reactants and products are gaseous. What is the value of Kp under this condition? We have to know first the partial pressures of those gases. So it means that we can say at the beginning or initial, and then reaction, and then equilibrium. For hydrogen, iodine, and hydrogen iodide. Okay. Now at the beginning, at initial, we have 3.60 mole of hydrogen and then 2.0 mole of iodide, and we don't have the hydrogen iodide at the beginning. This is iodine, yeah, sorry. And then after that, after the reaction, it means at the equilibrium, we have only 3.2 mole of the hydrogen, and then we don't know about the iodine and also the hydrogen iodide. But then we know that the difference between the initial and the equilibrium is 0.4 mole. So means it's what reacts. It means because if we see over here, the coefficient is 1 to 1 for the iodine, it means it takes also 0.40 mole. Okay. Okay, it starts to not look, doesn't look really tiny, sorry. And it means that what is produced, because the coefficient is 1 to 2, so it means 0.8 mole. So it means here at equilibrium, the mole of the iodine is 2.00 minus 0.40, or it means that 1.60 mole. And then the hydrogen iodide is previously or initially 0, means that it's not initially put over there into the system, but then it is produced by the reaction. So it means at the end or at equilibrium, it is 0.80 mole. Okay, so this is the composition of the moles of the gases at equilibrium. And then we know that the mole fraction, okay, mole fraction of, let's say, mole fraction of hydrogen equals to the moles of the hydrogen divided by mole total at equilibrium point, of course. So it means that the N total over here, okay, 3.20 plus 1.60 plus 0.80 equals to, we have here 5.6. 5.60 moles. Yep, okay. So it means the XH2 over here equals to 3.2 mole divided by 1.60 mole. And with the same way, we can find the mole fraction of I2. Yep. And then the mole fraction of HI. Okay. In short, we can say for I2, it means the mole fraction is 1.60 mole divided by 5.60 mole. We'll calculate it later together. And then the mole fraction of hydrogen iodide is 0.8 T mole divided by 5.60 mole. Okay, now let's check. Let's check. Okay, so it means this is 3.20 divided by 5.60, which is 0.571. Okay, we take 0.571. Yeah. Okay, and then after that here, 1.60 divided by 5.60 equals to 0.2857. So we just take so that it is also 3 decimals, so it means 0.286. We round it. And then, yeah, that's the fraction. So it means we don't have any unit over there because anyway, this is the unit mole divided by mole. It means that canceled, yeah? So it means no unit for the mole fraction. And then after that, 0.80. 0.80 divided by 5.60. It's 0.1428. So we count it into 0.143. Okay, 0.143. All right. And then after that, we know that the mole fraction, which is the mole of the item divided by the mole total, is actually the same with the showing also the partial pressure divided by the total pressure. So in this case, because we are trying to find the partial pressure, right? Yeah. Okay. What is the KP under this? We just leave the P total as P, as just P, yeah, because we don't have P over here. But I think it will somehow disappear later. Why my calculator become big? My calculator become really huge. Okay, there you go. All right, so it means over here, we use this. So I'll erase this one, yeah. I'll erase this because I'm going to need the space for doing the partial pressure and also the constant equilibrium constant of pressure. So it means over here, Kp equals to, okay. Now here, take a look, yeah. For example, XHI or the mole fraction of HI equals to the partial pressure of HI divided by the total pressure. So if we want to find this, it means that partial pressure of HI equals to, or hydrogen iodide, yeah, equals to the mole fraction of HI or hydrogen iodide multiplied by the total pressure, like this. So it means that we can say here we know the we know the mole fraction of the hydrogen ion. That will put it right away. So it means over here 0.143 raised to the power of 2 times P total raised to the power of 2, because it's raised to the power of 2, right? And then time divided by 0.57 times P total. Okay. So, sorry. So we are not going to get confused with between multiply and the mole fraction. So I'll just put point. Yeah. So 0.571 times P total times 0.286 times P total. Now, if you see over here, this one, P total, oh, sorry. Okay, if you see over here, P total multiplied by P total square. So we divide by the P total square. All right, so it means, in other words, we can say Kp equals to 0.143 raised to the power of 2 divided by 0.571 times 0.286. And now we calculate. Okay. All right, now it means over here we have 0.143 x2. Okay, so it means square 0.2. Okay, I'll just write down the whole, the whole thing first. 0.02044 divided by 0.571 multiplied by 0.286 equals to 0.163306 equals to 0.020449 divided by 0.163306 equals to 0.1252189 and so on. Okay, so in this case, we can say let's say take only 3 decimals, and then after that we round up or round down. In this case, we are rounding down. So it means it is 1.125. So that's our Kp, and it means the answer is B. Okay. All right, thank you so much. Goodbye.